12.4, that's page 198 to 199, dealing with compound measures. Whereas we've been dealing with lengths and weights and what's the other one we did? Lengths and weights and volumes and things like that. We now have to do with measures that involve two or more different things. So for example, speed is made up of distance and time. So you know that speed equals distance divided by time. So speed, if you like, has two ingredients, two components. It is a compound measure in the same way that one or more different elements chemically combined makes a compound. Same thing in maths, the same sort of idea. So compound measures, will be dealing with speed, distance and time. There's one here called fuel consumption, which will be given in miles per gallon. So we need to know the distance travelled and the volume of petrol or diesel used to get a compound measure of fuel consumption. And they're the two main ingredients really. This is mostly grade C work. There are about 10 questions here. I'll probably do aspects of 8 of them. So page 198, question 1, it says work out the average speed for each of the following and state your units. Well, the first one says a car is travelling 200 meters in 8 seconds. You know speed equals distance divided by time. So I've got meters and seconds, so 200 divided by 8. Grab my calculator quickly. 200 divided by 8. That gives me 25. And here are the units. I'm dividing meters by seconds. Please note that division line there is equivalent to that division line there. 25 meters for every second. 25 meters per second. I'll do the last one. Here's a train going 2 hours. So it's a 2-hour journey and it's travelling 230 miles. So we've got miles and hours. So speed equals distance over time. Distance 230 miles divided by 2 hours. 230 divided by 2 gives me 115 miles per hour. And because it's a British unit, that P, as opposed to an oblique slash line, is acceptable as MPH. Everyone knows MPH, miles per hour. That's question 1 done. Next one, express each of these times as a decimal fraction of an hour. Well, okay, you know 30 minutes is going to be half an hour straight away. In other words, 0.5 of an hour. Alright, 15 minutes, I just may as well do them all, there's only 3 of them. 15 minutes, you know, is a quarter of an hour, and a quarter is 0.25 hours. And the last one, which I will do, is 4 hours and 45 minutes. Well, 45 minutes is 3/4 of an hour, and 3/4 of an hour is 0.75 hours, isn't it? So altogether we have 4.75 hours. Alright, so please note not 4.45, because when it comes to calculations, students tend to think there's all of a sudden 100 minutes in an hour and 100 seconds in a minute. It's not, you know that, don't you? So be very careful how you convert bits of a minute, bits of an hour into minutes and vice versa. Be very, very careful. So these are really important, these ones here. Alright, especially that one, give it 2 stars. Just turn over quickly. Question 1, question 2 done. Now question 3 says write each of these times as hours and minutes. Right, I've got 1.75 hours. Okay, well that's 1 hour for a start, and this is 0.75 of an hour. Well, that's 3/4 of an hour, isn't it? And therefore 45 minutes. Final answer, 1 hour 45 minutes. Alright, study that one. Next one, find the speed in miles per hour of, and I'll do 4B, a lorry that travels 75 miles and it's in 1 hour 30 minutes. Okay, so speed equals distance over time, no trouble there. Distance 75 miles over 1.3, no. 30 minutes is half an hour, so we're looking at 1.5 hours and not 1.3. Like I said, as you know, there's not 100 minutes in an hour, so we divide by 1.5 1.5, not 1.3. Speak to the calculator. Divided by 1.5, and that is 50 miles per hour. Miles, hours. So mph is a good British unit. That's good. And that was question something or other. Let's do the snail. Question 5, do part B. A snail crawls at 5 centimetres per minute. That's quite a lot. Right, how long does it take to travel 1 metre? Right, well, 1 metre is 1,000 centimetres. So basically, how many 5s go into 100? So therefore, I've got 100. Better work with yellow. 100. Do it again. Actually, just rub it out properly. Don't get lazy. I've got 100 divided by 5. That's 20 lots. Therefore, 20 lots of 1 minute equals 20 minutes. Is that right? So it take us now 20 minutes to go 1 metre. That's pretty fast, I think. Just turn over the page. Work out the time. Question 6. I'll do a couple of these. Work out the time taken for each of these journeys and give your answer in hours and minutes. Let's do the first one. I've got 40 kilometres and I'm going at 50 kilometres per hour. Right. Yeah, okay, so that's my distance. That's my speed, and I want time. So speed equals distance divided by time. If you rearrange that, you get time equals distance divided by speed. Put in the numbers. Distance of 40, speed is 50, lose a 0. Well, that's going to be 0.8 of an hour. Look, it's time in hours. So it wants it in minutes now. Give your answer in hours and minutes. Well, I haven't got a whole hour, but I will convert my 0.8 into minutes. Take a look. If I have 0.8 of an hour, I have 0.8 times 60 minutes. It's that fraction of 60 minutes. Well, 6/8 of 48, so that's going to be 48 minutes exactly. Alright, I'll do the last one. A cyclist travels 45 kilometres, so that's a distance, at a speed of 25 kilometres per hour. So that's the speed. So using this formula, time equals distance divided by speed. Distance of 45, speed of 25. Just grab the machine immediately. I'll go 45 divided by 25 equals 1.8. So that's 1.8 hours. Now the 1 is 1 hour, no problem with that. Now the 0.8 will be 0.8 times 60, just like here. And we know that's 48 minutes. Therefore the answer is going to be 1 hour 48 minutes. Alright, dead easy. Now what else we got on the other page? Something. Let's have a look. This is Jan. Jan drives 255 miles. It's worth doing this question, definitely. Then what? And she uses 6 gallons of fuel. Ah, here we go. Right, so 255 miles requires 6 gallons of juice. Right, part A says, what is her fuel consumption in miles per gallon? Even if you did not know the formula, it says miles per gallon. So you're dividing the miles by the gallons. So here we go, fuel consumption. Is going to be the miles travelled divided by the gallons she used to do the travelling. Yes, it is Jan. So 255 divided by 6 gallons gives me 42.5 miles per gallon. And mpg is an acceptable unit. People know what mpg stands for in the UK. That's Jan. Now, part B says, how many gallons of fuel would Jan use for a journey of 400 miles? Alright, here I go. So I've got 255 miles needs 6 gallons, and 400 miles needs, I don't know, something X. Again, set up a simple ratio. I can say x over 400 equals 6 over 255. I can say x over 6 equals 400 over 255. Anything works. So here I go. Let's go for x over 6, matching gallons and gallons, equals 400 over 255, matching the miles with miles. The next step, as you know, take the 6 over and multiply. 400 divided by 255 and multiply by 6. So that's me setting up the ratio and using it. I've got 400 divided by 255 multiplied by 6, and that's 9.41 gallons of petrol or diesel, whatever she's using. Alright, that's straightforward. And part C, I'll try and make it fit up here, hope it does, says the fuel tank in Jane's car holds 15 gallons. Okay, 15 gallons max. Is it possible for Jan to travel 600 miles on one tank of fuel? Let's have a look. Right, so I know, let's just take a look. I know that 6 gallons is equivalent to 255 miles. Now let's set up a little ratio. I've got 6 dot 15 gallons and gallons equals 255 miles dot with mystery amount of miles. Now if I can work out x to be 600 or more, I'll let you know if we can do it or not. So to set up a ratio just here, I'm going to say x over 15, or I can say x over 255. Let's do over 255, makes no difference at all. So x over 255, so that over that equals 15 over 6. Okay, 15 over 6, then just take the 255 over and multiply, and let's see if we can get 600 out of this, shall we? Right, calculator. I've got 15 divided by 6 and then multiplied by 255. I have got, yes, Jan can do it, I've got 637.5 miles. Therefore, yes. Okay, it's good enough. And I'll stop there because that's fine. Alright.